Okay. Uh, First of all, I would like to thank the organizers for this kind invitation. So it's a really great pleasure to be here, this amazing place in this wonderful meeting, workshop. So I have learned a lot here. Thanks a lot, Matthias. I learned a lot from him. I have been discussing many things with him and many other people, of course. So today I'd like to talk to you about the development of solutions, quantum solutions for industrial and service segments in Brazil. I have a collaboration with a company. So, and this company develops solutions for other companies, for industries and many other companies in Brazil and in the world. So the outline of my talk follows basically these lines. So initially, I would like to talk to you about some basic research I have been developing in São Carlos, in the Federal University of São Carlos, with collaboration with people from many other places. And then I'd like to introduce you briefly the Ferner von Braun Research Center, named after the uncle's, Joaquin's uncle. So, and this company is the one that I have a collaboration. It's a research center that develops research and innovation for industry and service segments in general. So then I introduce you briefly the Entropic, that is the startup created by the Von Braun Center to develop solutions. And then I will finish to talk to you about some projects we are developing nowadays. So just to introduce you some of the results I have obtained recently. I have, for instance, this paper. Many of them are related to quantum information processing, basically investigating light matter interaction. So for instance, in this paper, in collaboration with Gerhard Rempe from Max Planck Institute, we investigated how to generate quantum light in a system composed by a single atom trapped in an optical cavity. The interesting point in this paper was that the atom is coupled to the cavity mode, coupling the transition 1 to 3, and the excited state, the third level, is never excited during the experiment. We carried out an experiment related to this paper. So the atom is never excited, but at the same time, it's able to emit light in the cavity mode. How this happened? Because there is an interference effect, basically the electromagnetically induced transparency effect behind of this study here. And then we could show that we can generate light, especially quantum light, with the atom never being excited. So in this other paper here, we investigated how to promote rotations in Fock space of a bosonic field, so a bosonic mode. So assuming that we have a two-photon Jaynes-Cummings model, then we could show that it's possible to generate rotations, arbitrary rotations in 0 and 1 photon states. So rotations like a Ramsey zone, a classical field applied to the mode of the field. In this other paper here, collaboration with people from China, we investigated how to implement conditional I-swap operation, so a logic gate that is fundamental for quantum computing. In this case, we could achieve an efficiency higher than 95%. And the interesting point was that we were able to turn on and turn off the interaction between closed qubits. So just assume that we have the collateral interaction together with an effective interaction we could derive. We could find a way to turn on and off the interaction between closed qubits. And a last result that I'd like to share with you is a collaboration with people from Stockholm University, the group by Marcus Heinrich. He works with trapped ion systems, and he could implement this idea we had some time ago. So using the interaction of the ion, the internal levels of the ion with the bosonic modes, vibrational modes, in this case, just a single mode of the ion, we could find a way to detect, to measure the number of phonons we have in the mode. So using basically a system similar to EIT, electromagnetic induced transparency, but in this case, using the Outlier-Town effect that it's proportional to the square root of the number of phonons we have. We could scan the frequency of the probe field, and then we could find easily the number of phonons we have in the mode. So this is an alternative way to measure, to detect phonon state. I have been involved in Brazil in many efforts to create national programs in quantum technology. One of them is specifically related to São Paulo state, but I'm not going to talk about this because this is exactly the talk by Paulo Nussensvai tomorrow. I invite all of you to be here because it's very important for us. And I'm also involved in projects including the Brazilian arms because they are interested in knowing how quantum technologies could help the security, mainly the cyber security in Brazil. Because in Brazil, the cyber security is given by the army, so they have to take care of this. So, of course, with the advent of quantum computing, as we said, we saw already, there is the possibility of breaking cryptographic systems, perhaps in the future. So we don't know. According to Matthias, this could be really, really far from in the future. Well, the Fernand von Braun is a company that has already a very long experience in developing solutions for industry and service segments. The name, of course, was given to this company after Fernand von Braun because the CEO of this company admires a lot Fernand von Braun because of the project of Apollo 11 and everything. So it's a research center. It's a private one, non-profit institution that develops basic research and innovation projects. It carries out scientific exploration and transformation, discovering in profitable applications in the market for the clients through spin-offs and its own projects. So they already developed many projects in collaboration with big companies like Toyota, Dell, Epson, and many others, with federal government in Brazil, with state government, and many others around the world. Many companies in Asia. So they have a long experience in taking the knowledge that is developed in the universities, in the academia, and transforming this knowledge in solutions. This is the goal of this company. They do. And they also work as a innovation lab for startups. There are many startups that were created by this group already, and one of them is related to quantum technologies, that I'm helping them to investigate how quantum solutions could help the industry and service segments in Brazil. So Anthropic is an initiative organized by a team of scientists. So we have many scientists involved already, engineers, technicians, business people, and the idea is to generate value on applications in the field of quantum mechanics. So the starting point is a little bit different of all we have seen here, because we work with real demand from the industry or from the companies. So we start with the real problem, and then the goal is to investigate how solutions, for instance, the solutions you are developing, so quantum simulations, quantum computing, sensors, and many others, could help us to solve the problems of the industry, of the companies. That are already partners of the Von Braun Center. So for instance, as a brief example here, there is a real problem in Brazil that is how we can measure the weight of trucks on highways. So this is a real problem because usually to build or to maintain those systems in Brazil spends a lot of money, more than billions of dollars per year, just to maintain the system working. So if we can have a cheaper system or a more efficient system, it would be great for us. So in this sense, the gravimeters, for instance, developed by Philippe Bouillet, I cannot see him, is really useful for, in fact, I am in touch with him discussing how these gravimeters could be used in this case. Perhaps it's not, but if we can use this. We are already developing other projects. One of them started more or less 3 years ago, in fact, it's related to secure communication. What is the point? Von Braun has already a partner that takes care of the tolls and free flow systems in Brazil, in many highways in Brazil. Perhaps the biggest company related to this there. And they take the information from the client on the roads and then send this message, the information to the computer center, process the information, and makes everything, of course. And what is the point here? They were worried about how they could have safe information traveling in the system, because they have all the information sent by optical fibers on the roads, on the highways. And with the advent of quantum computing, perhaps this could be an unsafe way to send information. And then they asked me to help them, how could quantum solutions help them to solve this problem? Of course, you know much better than me that quantum key distribution could be a way to solve their problems. So we started investigating how we could solve the problem they have. So this is why we went to the labs. So we looked for people that could help us. So this is the way we work. So I don't have experience in labs, but we know people that know how to do this. So for instance, people from Federal University of Minas Gerais, from Unicamp, from USP, Professor Vanderlei, Professor Daniel, and from Federal University of Ceará. And all of these people has different experience, different expertises that can help us to develop the devices we needed to solve the problem of security of information in the Von Braun systems they have already. Of course, they already are using very advanced cryptographic systems, classical ones, but with the quantum one, perhaps you can provide much better solutions. So recently, we got a project from CNPq, the Brazilian agency, so to develop even more things related to this, because the idea that is a national effort in Brazil to build the first quantum network in some cities there. And our group, together with other two, were chosen to start this project here. So when we started discussing how quantum technologies could help the industry and service segment, one point that was really important was that we recognized that there are a lot of confusion involving the people from companies and people from government. And then we recognized that we should start a specific training, education of these people. Also because we need the people to work on those technologies. So because of this, we started preparing classes, preparing material. For instance, here we have some example of classes we already recovered. And we have been doing quantum tech days. The idea is to invite people, to invite companies to be there, people from arms, they were already there, to see the quantum technology, the advantages we can have, the state of the art. I was very careful of showing them that we are really far from breaking the RSE cryptography systems. And also with hands-on, for instance, use the IBM systems. People from IBM helped us. They offered us all the materials to provide this course for them. So things like that we are doing there to help people to understand what are the benefits we can have with quantum technology. Another point, but this is in Portuguese, we wrote papers explaining how quantum computer works, how the system behind the quantum computer indeed we can have. For instance, in this case, the physics behind the IBM computer. In this way, the adiabatic quantum computing, so the physics behind the D-wave computers, the quantum annihilers computers, and also trapped ion systems. So we wrote this. The focus in this case is Brazilian, of course, because there we recognize that we need this. And we also have other projects. The last part of my talk is related to quantum computing. We don't have quantum computers in Brazil, but we can do algorithms. We can investigate how algorithms could help us to solve problems. So in this case, we We develop many kinds of algorithms because we are interested in real problems. And in this case, we investigate using classical annealing, genetic algorithm that is both classical, of course, quantum annealing, D-Wave, AI algorithms, KAOA, VKE, and quantum simulation. We do everything because we have a nice team. And we test those solutions, for instance, in AQT, D-Wave, IBM, Xanadu, the simulation they have, to find which of them could provide good solutions for us. So, for instance, we have many problems that we already addressed. For instance, differential equations. I'm not going to talk into detail because I have only 5 minutes. But we proposed an algorithm to solve differential equations using continuous variable protocols. There are problems related to optimization. There are many in the industry. This is one related to oil company in Brazil. They have many platforms over the sea. Many, I mean, something around 1,000. And then they need to distribute resources and people among all these platforms. Vehicle halting problem is also usual. And the last one, that is a problem that we were asked to solve, to investigate how quantum or classical could help them, because it's a real problem. A car manufacturer company in Brazil hired people from Von Braun Center to solve the problem they have. That is, there is a supply factory that makes the objects, the items, sent to warehouse to stock them, and then those objects will be used by the consuming factory. And in this case, we investigated how we could optimize the allocation of the objects inside the warehouse, because they had already a really big one, but they were thinking to build a new one because the space they had were not optimized to be used. So Von Braun was hired to solve this problem. They already made many solutions. They presented many solutions. They could improve the occupation of the warehouse, but still there is a problem that could be improved because they could organize in a better way using algorithms that could optimize the distribution of the objects there. So they have a system that is basically this one. So the question is, what is the best distribution of items on gravitational shelves in industrial warehouse in order to minimize the reinsertions and, of course, the machine and machine operator time within the factory. And that is an important point. This is a real problem, and the people from the warehouse has up to 3 minutes to deliver the object to the factory. So they have to solve this very fast. So this is the point. So they cannot wait for such long time to find a good solution. So nowadays, what they do, they just distribute in a simple way, and then that's it. But then we investigated how we could develop a solution, quantum solution to solve this problem. Not only quantum, but also classical one. And we tested those solutions. We used classical and quantum annealing in the wave, genetic algorithm, solutions with AI, optimization, as I said, KAOA, and variants of them. And we tested those solutions in all of these platforms. Even in a software, a commercial software, they could all be here. And these are the results. So if you fix the time, the runtime of the computer, classical or quantum, in 10 seconds, because they have to take the decision really fast, the best solution was obtained by the quantum annealing, the D-Wave computer in this case, surprisingly. But perhaps not surprisingly, because Matthias already told me why this could happen. I'll tell you why. In the other way, instead of fixing the runtime, we just asked for the computer to provide us the best solution, independent on the time they needed. And in this case, the hybrid algorithm took 1.6 minutes, while the classical algorithm, the best one, yes, 10 minutes. But remember, the tolerable delay to deliver the object is less than 3 minutes. So the classical solution in this case does not work. It seems to be a good result, but there are many questions, of course. And I thank a lot, Matthias, for advertising me. One of them is, are the classical solutions obtained the best ones? Among the set of solutions we had, among the solutions that the company has, the quantum one is the best one. But this does not mean that this is indeed the best solution ever. Of course, we need to investigate much more. I mean, using, for instance, matrix product states, digital annealing, that is the classical annealing, and many other solutions in order to claim that we have a small advantage here. And another interesting point is, again, thanks to Matthias, quantum annealing from D-Wave can provide good solutions because of its quantum properties or because it performs analog computing. Because analog compute can be much faster for specific problems. And this is an interesting question because people from D-Wave, of course, they claim that it's due to quantum advantage. But perhaps it's only because of its classical analog computing. So this is with this we can think about, could we develop other annealers, classical annealers, for instance, based on semiconductor devices that could solve the same problems? If you do, we have a market for them. As many people already said, we can make money with this. So this is the people involved in this part, only in the optimization problem. There are many other people involved in differential equation algorithms and many other. And with this, I would like to finish this, and thank you.